All right, good luck, guys. All right, math brainiacs, here's Thursday. In the dryer, there's 18 red socks, 24 white socks, 8 blue socks, 10 black socks, and Fred wants to have 2 matching socks to wear. Good job, Fred. He reaches into the dryer without looking and pulls out 1 sock at a time. So what's the minimum number of socks he needs to pull out to make sure he has a matching pair? We had quite the discussion about this problem in class, and Mrs. Ogle approached this problem in a couple different ways. I saw I had a bunch of different colored socks, and then I saw I had a bunch of different number of those colors. So my mind went to making possibly fractional pieces. I was trying to do some ratios here. But what I couldn't figure out is the minimum number of socks he'd need to pull out to make sure he had a matching pair. It didn't seem to coincide with the numbers they were giving me. So as you know, hopefully you were paying attention in class, I decided to work backwards, and I found the answer, hoping to better explain the process to you guys. And the answer didn't really give me what I wanted. And so I kind of gave you a freebie on this one. The answer, we said, was 5 socks. Okay, that's what they said. Because, and this is the why, okay, they said the first 4 socks could each be a different color, but that by the time you pulled that 5th sock out, you would have matched one of the first 4. Because remember, I had red, white, blue, and black. So they're assuming in the problem that I'm reaching in to my dryer here. Here's my dryer. Okay? Pulling open that door, and I would just magically get a red, a white, a blue, and a black. So by the 5th sock, I would have pulled, the match. The other red, the other white, the other blue, and the other black. But as many of my smart mathematicians pointed out, and I agreed with them, how can I guarantee that I'm going to pull one of each color? If we look back at the problem, I had 24 white socks. That's the most. So isn't it possible then I could have pulled a white sock, a red, and a blue? How can I guarantee then on the 5th pull that I would have a match for one of those? So I don't think the problem was very well thought out. So that's kind of our freebie there for you guys. I don't necessarily agree that the 5th sock would match one of the first 4. But there it is. They said it would be, you'd have to pull out a minimum of 5 socks in order to get that match, which, according to these numbers, I don't necessarily agree with. So we win some, we lose some. All right, so which brings us to Friday, our data page. It says the following chart shows the number of minutes that a washing machine took to wash 5 different loads of laundry. So anytime you have a graph, you want to observe that. You see on the y-axis, we have the number of loads. Along the x-axis, we have the number of minutes it took. You can see the interval they chose was 5. And then, so for each of those loads, it gives you how long it took for that particular load. So what we need to use from this data is what was the average length of time for the 5 loads. Well, average is a term we've been using over and over again, not only in our POW, but in our starters we've seen a lot. Anytime we find the average, that's also called the mean, in case you were wondering, it's a 2-step process. I'm going to first need to add my data, and then I'm going to need to divide by how many numbers I added up. So when I look at my data, if you look at the chart I circled there, I've got my 5 numbers. So I'm going to need to add those length of times up and divide by 5 in order to get how much time about that would be. Now, you are allowed to use your calculator provided you show your work. And most averages work out nice and even. This one doesn't. So you have two options here. You can either leave the time as a decimal, or you can turn it into a fractional part for your answer, or you can even round to the nearest whole number. So you have some options in terms of reporting your answer on this one. All right, good luck, guys.